So we're going to talk in this video about the dot product of two vectors. So the dot product is kind of sort of related to multiplication. There's no real multiplication of vectors. And so if you have two vectors, say I have vector v, which is equal to ai plus bj. And let's say I had vector w, which is equal to ci plus dj. Then the dot product, which we would write as v dot w, is equal to, so what we're going to do is we're going to multiply the x components together, so those I components, so it's ac, and then we're going to add to it multiplying the coefficients of the j vectors together. So AC plus BD. So it's interesting, the dot product of two vectors actually gives us a number. We call that a scalar. So it's not giving us a new vector, it's actually just giving us a number. So for example, given vector S equals 2i minus 3j, and vector t is equal to 5i minus j, find s dot t. So s dot t, we're going to multiply the x components together, those I components. So 2 times 5 plus, we're going to multiply the j components together. So negative 3 times negative 1. So in this case, we end up with 10 plus 3, or 13. So we'll try another one here. Given vector v equals to minus vector I minus 6 vector j, and vector w being equal to minus 8 vector I plus 3 vector j. We want to find v dot w. So v dot w is equal to, so the I components is going to be negative 1 times negative 8. And the j components are going to be negative 6 times 3. So negative 1 times negative 8 would give us 8. Negative 6 times 3 would give us minus 18. So this is going to end up being negative 10. So the dot product can turn out to be negative. It's just what you get when you multiply the I components together and then add them to multiplying the j components together.